Earth's meteorite impacts over the past 500 million years have now been tracked. This is by Lund University. For the first time, a unique study tracked the meteorite flux to Earth over the past 500 million years. Contrary to current theories, researchers have determined that major collisions in the asteroid belt have not generally affected the number of impacts with Earth to any great extent. Researchers have been studying geologic series since the 19th century, and this was in order to reconstruct how flora, fauna, and the climate have changed over millions of years. Until now, however, almost nothing has been known about ancient meteorite flux, which makes sense since impact is rare, and the battered celestial bodies quickly break down as they encounter Earth's oxygen. A new study published in PNAS shows how researchers in Lund University have reconstructed meteorite bombardment towards Earth over the past 500 million years. The research community previously believed that meteorite flux to Earth was connected to dramatic events in the asteroid belt. The new study, however, shows that the flux has instead been very stable. This is what Brigitte Schmitz, professor of geology at Lund University, says. To conduct the study, the researchers at Lund University's astrogeobiology laboratory dissolved almost 10 tons of sedimentary rock from ancient seabeds in strong acids because the sediment contains residue from meteorites dating back to when they fell on Earth. Meteorites contain a small fraction of mineral, a chromium oxide, which is very resistant to degradation. The microscopic chromium oxide grains were sifted out in the laboratory and serve as time capsules with an abundance of information. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. The dissolved sediment represents 15 periods over the past 500 million years. In total, we have extracted chromium oxide from almost 10,000 different meteorites. Chemical analysis then enabled us to determine which types of meteorites the grains represent, said Brigitte Schmitz. A couple of thousand meteorites land on the Earth's surface every single year, and approximately 63,000 space rocks have been documented by science. The space rocks originate from the asteroid belt between Mars and Jupiter, where battered celestial bodies from gigantic collisions revolve around our Sun. Brigitte Schmitz said, "We were very surprised to learn that only one of the 70 largest asteroid collisions that took place over the past 500 million years resulted in an increased flux of meteorites to Earth. For some reason, most of the rocks stay in the asteroid belt," he said. Now, this is about the asteroid belt. We're not talking about the Oort cloud. If you see the video before this one, there are astrogeobiologists that say that because our solar system goes through the plane of the Milky Way galaxy, they have comet impact. We have comet impacts from the Oort cloud happening cyclical every 26 million years. This has to do, though, with the asteroid belt between Mars and Jupiter. Now, for some reason, he said most of the rocks stay in the asteroid belt. The study not only upends generally accepted meteorite flux theories, it also provides entirely new perspectives on which types of celestial bodies are at greatest risk of colliding with Earth and where in the solar system they originate. From a geological time perspective, kilometer-sized celestial bodies collide with the Earth on a regular basis. One such event took place 66 million years ago when the celestial body stretched over 10 kilometers in size, hit the Yucatan Peninsula, and the impact was part of the reason the Earth went dark and the dinosaurs starved to death. That was the dinosaur extinction event. Brigitte Schmitz says future impact from even a small asteroid, for example, in the sea, close to a populated area, could lead to disastrous outcomes. This study provides important understanding that we can use to prevent this from happening, for example, by attempting to influence the trajectory of rapidly approaching celestial bodies. And this is from Lund University on Science Daily. Of course, he's talking here about the asteroid redirect missions, or the DART missions that we have that's going to the twin asteroid in order to take out the moonlet and push it away from it, impact it, pushing it away from its trajectory as a sort of a dry run for Earth protection systems. Please leave your comments, and thank you for your support.